What is a drone? A drone, also known as an unmanned aerial vehicle (UAV) or unmanned aircraft system (UAS), is a remote-controlled aircraft that can fly autonomously or be piloted by a human operator from the ground. Drones are equipped with various sensors, cameras, and sometimes even other specialized equipment. They are used for a wide range of purposes, both civilian and military, due to their versatility, maneuverability, and ability to access areas that may be difficult or dangerous for humans to reach. Drones can vary in size, design, and capabilities. Some drones are small and lightweight, while others are larger and more complex. They can be used for tasks such as aerial photography, surveillance, search and rescue, scientific research, mapping, agricultural monitoring, delivery of goods, and even recreational flying. Modern drones are typically powered by electric motors and use advanced control systems, including gyroscopes, accelerometers, and GPS technology, to stabilize and navigate. They can be controlled remotely through handheld controllers, mobile apps, or even programmed to follow predefined flight paths. The popularity of drones has grown significantly in recent years, leading to advancements in technology and regulations governing their use in various countries. It's important for drone operators to be aware of local laws and regulations related to flying drones, as they vary depending on factors such as location, drone size, and purpose. How are drones made? Drones, also known as unmanned aerial vehicles (UAVs), are built through a combination of various technologies, materials, and components. The specific construction process can vary depending on the type of drone, its intended purpose, and the manufacturer's design. Here's a general overview of how drones are made. Design and planning. Engineers and designers create a blueprint or digital model of the drone, considering factors like size, shape, weight, payload capacity, flight range, and the required sensors and equipment. Frame and structure. The frame serves as the foundation of the drone. It can be made from materials such as lightweight plastics, carbon fiber, aluminum, or composite materials. The design of the frame affects the drone's strength, stability, and overall weight. Electronics and avionics. Drones are equipped with electronic components such as flight controllers, sensors, accelerometers, gyroscopes, GPS, and communication modules, transmitters and receivers, that allow remote control and autonomous flight. Propulsion system. Drones use one or more motors with attached propellers for lift and propulsion. The number and configuration of motors and propellers depend on the drone's design and intended use. Electric motors are commonly used for their efficiency and controllability. Power source. Drones require a power source, usually in the form of rechargeable lithium polymer (LiPo) batteries. Battery capacity and voltage play a role in determining the drone's flight time and performance. Flight controller. The flight controller is the brain of the drone, processing data from various sensors and adjusting the motor outputs to maintain stability and control. It uses algorithms to stabilize the drone during flight. Communication systems. Drones use communication systems to receive commands from the operator and send back data such as telemetry, video feeds, and status information. Payload integration. Depending on the drone's purpose, it may be equipped with cameras, sensors, LiDAR, light detection and ranging devices, thermal imaging cameras, or other specialized equipment. These payloads are integrated into the drone structure while considering balance and aerodynamics. Software integration. Drones rely on software for flight control, navigation, autonomous flight, and data processing. Software engineers develop the algorithms that allow the drone to perform tasks and follow flight plans. Testing and calibration. Once the components are integrated, the drone undergoes rigorous testing and calibration. This involves checking sensors, motors, flight controllers, and communication systems to ensure they work correctly. Quality control and safety checks. Manufacturers conduct quality control checks to ensure that each drone meets safety and performance standards. Packaging and distribution. Once the drones are manufactured and tested, they are packaged for distribution to retailers, customers, or organizations that will use them. Overall, building a drone involves a combination of mechanical engineering, electrical engineering, software development, and quality control to create a functional and reliable aerial vehicle. The complexity of the process can vary depending on the sophistication and capabilities of the drone being produced. What are the uses of a drone? Drones, or unmanned aerial vehicles, UAVs, have a wide range of uses across various industries and sectors due to their versatility and ability to access remote or difficult to reach areas. Here are some common uses of drones. Aerial photography and videography. Drones equipped with high-resolution cameras are used for capturing stunning aerial photographs and videos for filmmaking, photography, real estate listings, tourism promotions, and more. Mapping and surveying. Drones can create accurate 3D maps, models, and topographic surveys of landscapes, construction sites, agricultural fields, and other areas, saving time and resources compared to traditional methods. Agriculture. Drones equipped with multispectral or thermal sensors can monitor crop health, detect diseases, assess irrigation needs, and optimize agricultural practices. Environmental monitoring. Drones are used to monitor wildlife, track changes in ecosystems, and gather data on air quality, water quality, and pollution levels in remote or hazardous environments. Search and rescue. Drones equipped with thermal cameras and other sensors aid search and rescue operations by locating missing persons or survivors in challenging terrain and providing real-time situational awareness. Infrastructure inspection. Drones can inspect infrastructure such as bridges, power lines, pipelines, and cell towers, identifying defects, corrosion, or other issues without the need for humans to access hazardous locations. Disaster response. Drones assist in disaster assessment and response by rapidly providing aerial views of affected areas, helping authorities plan rescue operations and allocate resources. Delivery services. Some companies are exploring the use of drones for delivering small packages, especially in remote or hard-to-reach areas where traditional delivery methods may be less efficient. Construction and engineering. Drones aid in monitoring construction progress, conducting site surveys, and assessing the structural integrity of buildings and infrastructure. Wildlife conservation. Drones are used to monitor and track wildlife populations, prevent poaching, study animal behavior, and protect endangered species. Media and journalism. Journalists and media outlets use drones to capture aerial footage for news reporting, event coverage, and documentary filmmaking. Scientific research. Researchers use drones to collect data in fields such as geology, archaeology, ecology, meteorology, and oceanography, allowing them to access hard-to-reach areas. Security and surveillance. Drones equipped with cameras and sensors provide surveillance for large events, public spaces, borders, and critical infrastructure, enhancing security measures. Oil and gas industry. Drones are used for inspecting oil rigs, pipelines, and facilities, as well as monitoring environmental compliance in the oil and gas sector. Entertainment and sports. Drones are employed in entertainment events, sports broadcasts, and live performances to capture unique aerial perspectives for audiences. These are just a few examples of the diverse applications of drones. As technology continues to advance and regulations evolve, the potential uses of drones are likely to expand even further. Please like this video if you like the content. Share this video with your friends, near and dear ones. Want to say something? Use the comments section to do so. For more interesting videos like this, do subscribe to my channel at Pagojai TV. Thank you.